While printers and printing machines are one of man's greatest and most useful inventions, these devices also represent a finite ecological and financial cost in terms of paper, ink, and electricity. In many parts of the developing world, such as rural schools and clinics, these costs can also represent a significant barrier to accessing even the very basic of information technologies. The EcoPrinter Project was created to challenge conventional assumptions about printing and to explore simple engineering design. We set out to create a printing machine that uses only renewable energy and no consumables. Such a printer could be outfitted with a low-power wireless link that can receive data from a nearby PC and also perhaps from a local broadcast radio station. In its simplest incarnation, the EcoPrinter is a programmable stencil wheel which shapes the light projected on a printing surface. Rather than pulling the paper through the machine, we were interested in creating a machine which moves over the paper. This allows for printing on a variety of materials comprising a wide range of sizes and thicknesses. Instead of ink, the EcoPrinter makes use of photochromic materials, which change color when exposed to certain wavelengths of light. While conventional photochromic inks have been used for decades to create color-changing fabrics and novelty items, these materials are simply activated by ultraviolet light, but slowly fade when brought indoors. More recently, however, new reversible forms of organic photochromic compounds have been created, which have greater stability and can be both printed and erased using different colors of light. To illustrate the use of these new materials, here we show how a focused sunlight beam can be used to selectively erase a sheet of photochromic paper that had been previously activated by ultraviolet light. Using this method, it is possible to generate white letters on a magenta background. The current EcoPrinter design consists of 3 small motors, 2 for the body and 1 for the stencil. By using low-power DC motors instead of servo motors for the body, we were able to create a design that is very low cost and consumes only 0.4 watts of power, which is less than most cell phones. Using a rechargeable battery and a solar-powered charger, the EcoPrinter can run for over 40 hours on a single charge. While the outdoor use of the EcoPrinter requires proper alignment of the sunlight and lens, a more practical configuration makes use of an alternate light source in the form of a low-power ultraviolet LED. By starting with the paper in its blank state, the LED is used to print magenta letters on the white background. The printing time and contrast can be adjusted by varying the brightness of the LED, depending on the desired power consumption. Our current design has been set to a very slow printing speed in order to minimize the power consumption. Here we see the EcoPrinter printing the word design. And finally, we demonstrate how the printed letters can be erased, using a green flashlight to reset the paper back to its blank state. We hope that our simple EcoPrinter demonstration will help to stimulate the design of future consumer products that will be ecologically responsible and have sufficiently low operational costs to make information technology accessible to people in all parts of the world.